Okay, here we're trying to determine the interval and radius of convergence for this power series. And so in order to do that, we're going to use the ratio test. So we're going to look at the limit as n goes to infinity. We're using absolute values, so we're not going to worry about this -1 to the n. And we have x minus 2, we're looking at the n plus 1 term, over 4 to the n plus 1, and since we're running the ratio test, we would divide that by the nth term. So we're going to multiply by the reciprocal of the nth term. That would look like that. Now let's see what we can do to simplify. We know that x minus 2 to the n plus 1 is x minus 2 to the n, and then times x minus 2 to the 1. So here our x minus 2 to the n's would cancel and leave us just this x minus 2 to the 1. Same down here, this is 4 to the n times 4 to the 1, and so the 4 to the n's can cancel. So now we're going to bring this x minus 2 out in front of the limit because it doesn't involve n, but it does need to be inside of the absolute value signs. And so then we have the limit as n goes to infinity. And what we have left here is just 1 over 4. So as we look at this, it looks like all of our n's canceled, and so this limit is just 1/4. And so we need this whole thing to be less than 1. So we basically have 1/4 times the absolute value of x minus 2 needs to be less than 1. So let's go ahead and multiply by 4 to get rid of the fraction, and then we could express this absolute value in terms of a compound inequality. So we have -4 is less than x minus 2, which is less than 4, and then we could add 2 to both ends, and we'd have -2 is less than x, which is less than 6. We now know the center of our interval, because if we had here -2, -1, 0, 1, 2, 3, 4, 5, and here we had 6, we could find that the center of our interval is going to be right here at 2, and our radius of convergence then is going to be 4, because our total interval length, if we did the 6 minus the -2, is 8. So our radius of convergence is half of that. So our radius of convergence is 4. Now our interval of convergence is going to involve -2 and 6, but we need to test the endpoints to know whether we include the endpoints or not. So we're going to go back to this original, and we're going to put in -2. So if I put a -2 in here, I would have -1 to the n, -4 to the n, over 4 to the n, and I'm looking at the sum. And so when I'm doing that, now let's see what we have. I could actually take a -1 to the n out of this, and I'm going to do that. Now these would cancel, and then I would just have -1 times -1 to the n, which is just 1 to the n, and we can see that that diverges because that would just be, keep going, adding 1 each time. So we are not going to include the endpoint -2. Let's try the endpoint 6. So if we looked at this sum, and we had our -1 to the n, and we put in 6 minus 2, that's 4 to the n, over 4 to the n. And so then we could see that these would cancel, and we would have -1 to the n. So it's going to keep going. It's not going to converge to one specific value, and so this one is also not going to be included. So our interval of convergence is going to be from -2 to 6.